Hello students, I hope you all are doing well, and today we are going to start unit number 2, probability theory. As you can see on the screen, there's a syllabus of this unit, and here basically 9 lectures are devoted to cover all the contents of this unit. Okay, I have already shared with you the lesson plan of this unit, and we are going to strictly follow that because I think that will help us to be on track first of all, and it will help us to finish the course on time. Okay, so in this lesson number 1, we are going to start with basics of probability. Okay, so here whenever we learn about the theory of probability, so we have two main approaches. First is the classical approach, and second is set theoretic or axiomatic approach. We will learn about this approach as well, maybe in lesson number 3, but today in this lesson we are going to learn about classical approach of this probability of theory. Okay, so we will use this approach and we will move further, but here first of all let me introduce a few concepts here so that we can understand the definition of probability. Okay, so here first of all we need to understand what is random experiment and events. So here the definition says an experiment which does not give unique result when repeated under essentially identical condition is called a random experiment. Okay, suppose you are tossing a coin, okay, and suppose you are throwing a dice. So in these two examples you may predict you have a number of certain outcomes. Okay, but here is an uncertainty that you are not sure that which thing or which event is going to happen at this particular moment. So that means there is an uncertainty. There is a not unique result, outcome in a particular experiment, in a particular environment. So that is not depend on any condition. Okay, so that is totally random. That is why these type of events, these types of experiments are called random experiment. Okay, I think you are getting my point. So now, and these outcomes, whatever outcomes comes in an experiment, that is called the events or cases. Okay, so here are few examples like getting a head or tail is an event when we toss a coin. Okay, or getting any of the 6 spaces out of these 1 2 3 4 5 6 is an event when we throw a die. Okay, so these are few examples, and I hope now you have understood this concept. Now let's move on the exhaustive events. So basically the total number of possible outcomes in a random experiment or trial are known as exhaustive events. So that means whatever happens, okay, whatever are the possible outcomes, those possible outcomes are called exhaustive events. For example, when we toss a coin, so what are the possibilities? Head and tail. So head and tail are going to be the exhaustive event, okay, when we toss a coin, and these are two exhaustive events. Okay, when we throw a die, so there would be 6 exhaustive events when we throw a die. Okay, so here 1 2 3 4 5 6. Okay, now let's talk about the sample space. So if we write all these possible outcomes in the form of a set, say suppose if I collect all those possible outcomes here and I put in the form of a set, so this set is called the sample space. For example, again, if I toss a coin, so what would be my sample space? That sample space would be head and tail. If I throw a dice, then what would be my sample space? It would be 1 2 3 4 5 and 6. Okay, if I throw two if I toss two coin at the same time, what would be my sample space? So it would be S equals to like head head, head tail, tail head, or tail tail. Okay, tail tail. So this would be my sample space. I think now you are getting all possible outcomes when we collect all those and we put in the form of a set, that is called the sample space. Okay, so now it is clear. Now let's move on further on the favorable events. So basically definition says the events which cause the happening of a particular event, okay, are called the favorable events. For example, when suppose we throw a dice and we are interested in an even number. Okay, so what would be my favorable event? My favorable events would be 2, 4 and 6 because I am interested in even numbers. So if 2 comes, so that would work. Okay, if 4 comes, that is fine. If 6, then it's again fine, it's okay. So that means there are these three favorable events for the occurrence for this event which I'm interested. I'm interested in even numbers. Okay, if I'm interested in odd numbers, so what would be my favorable events? In that case, that would be 1, 3 and 5. Okay, I think now you are getting my point. Okay, so these are called the favorable events. So now just a minute. Okay, so mutually exclusive events. So basically definition says such events where the occurrence of one rules out the occurrence of others, okay, are called the mutually exclusive events. So that means when if one happens, so that means second will not happen, other will not happen. So if these type of events we see in an experiment, so those events are called mutually exclusive events. For example, if when we toss a coin, definitely there are two mutually exclusive events. Okay, because if head comes in a trial, then definitely tail cannot come in the same trial. Okay, so that means an event controls or rules out the occurrence of the other event. So these types of events are called mutually exclusive. Okay, those events cannot happen at the same trial. Okay, I hope now this is clear. Now let's move on the equally likely events. So the events are said to be equally likely if none of them is expected to occur in preference to others. So that means if each and every event has equal chance to appear, okay, to become as a result, so that means those events are called equally likely events. Okay, if they have equal chances. For example, head and tail. So if we toss a coin, so head has the equal chance and tail at the same time. Okay, so head and tail are the equally likely events. Okay, I hope now you have understood this concept. Now, now let me give you the definition of the probability. So this is the basic mathematical or classical or prior definition of probability. Okay, and it says, if there are n exhaustive, mutually exclusive and equally likely events, okay, out of which m are favorable to the happening of an event, then probability of happening of event A is defined as probability of A equals to m upon n. What is m? M is the favorable cases and n is the total cases. That means exhaustive number of cases. Okay, or how I use like this definition, I just use like number of A upon number of S, because here we are interested in counts, numbers. So I can write even n of A upon n of S. This would be fine. For example, suppose when we toss a coin, okay, and so in that case, what would be my sample space? Sample space would be like either head will come or tail will come, although this is a that is the set a theoretic approach, but still the exhaustive event or sample space here would be head and tail. And in suppose I am interested in head, so A would be head only because I am interested in head. So what is n of S? N of S is 2 here and n of A is 1 here. So what, by definition of probability of getting head is equivalent to 1 upon 2, number of A upon number of S. Okay, I hope this is clear. So this is how we can use this definition. Now we have few important notes, important points. You should keep all these 4 points in mind. Okay, so here first point is probability of A bar. Basically A bar is representing not happening of A. If PA representing the probability of happening A bar is representing not happening of A. and that would be 1 minus P of A. Okay, in some time I know you have little idea about the probability theory. You have already studied in your 12th standard. If you remember, we used to write P plus Q equals to 1 and Q equals to 1 minus P. That is the same thing. Okay, now you must understand that probability of any event lies between 0 and 1, and if the probability of A is 0, so that means that event A is called the impossible event or null event. If the probability of A is 1, so that A event is called certain or sure event. For example, like what is the probability of rising the sun in the east? So that is a certain, that is the sure event. So its probability is 1. Fine. So now third point is we must remember this thing, that probability of A plus B basically represents probability of happening A or B. Okay, and probability of AB here represents the probability of A and B simultaneously. Okay, so here the fourth point is, if there are two events A and B and those are not mutually exclusive, suppose. Okay, so that means those are not that much dependent. Okay, you can understand in this way. Then probability of A or B is equivalent to probability of A plus probability of B minus probability of AB. Okay, but if those events are mutually exclusive, that means if one happens, second cannot happen, so in that case probability of AB would be probability of A plus B, because in that case probability of AB would be 0. Okay, so because there would be nothing in common. Okay, so these 4 points you need to remember, and now I am taking few examples, few questions to just demonstrate whatever we have studied in this lecture. Okay, so here is my first example. Find the probability of getting an even number in the throw of a single die. So again, basically what would be my sample space in that case? S would be like 1, 2, 3, okay, 4, 5, 6, or I can say what is my exhaustive event. So exhaustive events are number of exhaustive events are 6, because all these are the 6, and number of favorable cases of favorable cases are basically even numbers, so these are the 3. So definitely probability of getting this even this event, and this, suppose A is representing here getting an even number, this would be 3 by 6, that is 1 by 2. Okay, so you have to write in the proper way, because I am writing quickly here, and it seems very rough, but you have to write in the proper way. Okay, now let me take another example. In a single throw with 2 dice, this time we have 2 dice, and find the probability of getting total of 10. So basically I am interested, my event is getting total 10. So in which manner I can get these total 10? If in the first 4 appear and in the second die 6 appears, so this would give me the total 10, or 5 in the first, 5 in the second, or 6 in the first, or 4 in the second. So these are the 3 possible cases or favorable cases. So number of A would be here what, 3, and S would be the total number of sample spaces, N of S would be 36, because if I would write all these pairs, so these would count 36. So let me express, like, if you, let me give you the hint, because if we write like 1 in the first die, 1 in the second die, 1 in the first die, second in the 2 in the second die, like this, or it would go to 1 to 6, then 2 in the first die, and 1 in the second die. So likewise you can have total 36 cases. Okay, 6 and 6. So total number of exhaustive events would be 36. Okay, so probability of A is here basically 3 upon 36, that is 1 by 12. Okay, now let me take another example. Say here 2 cards are drawn at random from a well shuffled pack of 52 cards. Okay, so find the probability of getting two S's. So here, see, it will be very difficult to write a sample space. So whenever we have such kind of things, if we are choosing you know choosing something out of total, then we use combination definition. Combination. Okay, NCR, basically NCR tells me the ways. Okay, in how many ways, in how many ways this are things we choose out of 9, out of these n. So this NCR gives me the idea of number of ways, okay, that are in, like say suppose I have three things. One, say suppose A, B and C, and I want to choose two out of these three. So I have total 3C2 ways to choose two out of these three. Okay, so that means NCR is factorial 3 factorial R. NCR is factorial, just a minute. Okay, so here NCR basically factorial n, factorial r and factorial n minus r. This is the formula. So here it would be factorial 3, factorial 2 and factorial 3 minus 2, that is 1. So I am going to have basically three choices. How? Like if I select AB, I can select AC, I can select BC. Okay. So likewise I will have total 3 cases. So here I will use this definition, and here just actually I have to select eraser, so you just give me a second. Okay, so here total number of S would be, I am interested to getting 2 cards, okay, out of 52. So out of 52 cards I am getting 2, I am drawing 2 cards. So this is my total number of getting these 2 cards. Okay, now I am interested in A. A is what? A is basically I am interested in 2 aces. So number of aces would be, out of 4 aces, we know that there are 4 aces, so out of 4 I am interested in 2. So this gives me the number of ways in which I can get 2 aces. So now the probability of A would be n of A upon n of S. Okay, so this is going to give me the answer of this question. Okay, so I hope this is clear, but still we will discuss all these problems in the live session as well. Okay, so here now I am having 2 more questions. From a pack of 52 cards, find the chance that one is king and other is queen. So here like n of S would be directly here what? I am drawing 2 cards, so that means 52C2 would be my NS. But n of A would be out, actually I am interested in a king and a queen. So there are 4 kings, so out of 4 I am interested in 1, and for the and I have to use this multiple sign. So and out of 4 queens I am interested in 1. So this is going to give me the total number of ways in which I can get my this event fulfilled. Okay, so finally I will get my answer. P of A is equivalent to n of A upon n of S. Okay, so this would be my answer. Now last question is, one card is drawn from a pack of 52 cards. Then find the chance that a card is either a spade or an ace. So see, I just give you the point that when we have 2 things A and B, and we are interested in A or B, so we write in this way: P of A plus P of B, and that is equivalent to P of A plus P of B minus P of AB. And if those events are mutually exclusive, then this goes to 0. But here, just understand, we are interested in in either a spade. So it may be a spade or a ace. Okay, so probability of a spade plus probability of an ace or minus probability of a spade and ace. So here there are total 13 spade, we know this thing. So this would be like 13 out of 13 C1 I will get one card, and there are total 52 cards. So total 52 out of 52 cards I am interested in one, plus probability of A, that means probability of ace. There are 4 aces, so out of 4 aces I am interested in one, and out of 52 cards this would be the total number of cases. And minus, you should understand this is for the and, for the common thing. So there is a card which is spade and an ace at both. So that means there is a one single card which is both. So we are going to use that as 1C1 upon 52C1. So this will give me the answer like 13C1, 14 like this. Okay, and the final answer you will get 16 by 52. Okay, so this is how we use all those concepts, because in the probability you have to work when as you speak. Okay, so we will work upon all these type of questions in live session as well, but still you are welcome to you are free to ask any questions at any time. Okay, contact me. Because until you solve those problems, all these problems, you won't be able to solve new problems, or you won't feel good or feel confident. Okay, so I request you to please practice all these questions. I will upload a quiz as well, few questions for the practice. Okay, so by then I keep practicing, and let me summarize that in this lesson we have just talked about the classical approach. Okay, we learned few concepts and we learned the definition of a probability, and we saw few examples how to apply that definition. Okay, so keep studying, and thank you so much.